What can you see on the screen? What can you see?
Lens. Oh,
Nampak saya boleh?
Nampak?
light.
Okay, can you see the convex lens and concave lens on my screen?
Yes.
Yes.
Boleh, sir.
Okay,
Sorry,
good.
sir.
Now we are going to apply the 3 rules we have learned in 6 situations. 6 situations. Last week we have learned that light, parallel light, which comes from distant object, or the object is very far away. So light will be parallel. Remember, light will be parallel if the object is very, very far away. So what we do is we apply the rules. Okay, I'm going to use another color. But before that, I'm going to change. I'm going to correct this diagram. As I told you, this is what? This is. Remember, this is what?
Mana?
C.
C.
Okay, this is C, not 2F. Okay, I'm going to change the color of the pen. Okay. The third rule: if light travels through F, it will go straight on. Remember. Remember, when you're drawing this, you need to use your ruler. But I'm not using it now, right now, because I want to make it quicker. But you have to use your ruler when you are doing it in examination. So when light travels through F, what happens?
Parallel to the principal axis.
Yes, that's right. It will be parallel to principal axis. So when the two lines here parallel, then you're going to see the image is formed exactly on F. Right. So we are going to do the same thing for concave mirror. This time, okay, this time light travels through F. What happens? It will be
Reflected.
reflected parallel to principal axis, right? And then, what if
Yeah.
we have another line which is parallel? Remember, this case is light is very far away. Now, it will fall. Okay, it will be reflected back on the same line. Remember, as I told you. So you must draw the line, dotted line. Now what happens is we have the image exactly on F over here. Okay, you see that? Or I'm going to change the color for the image so that it's clear for you. Okay, this is the image of the object. So you can see in this case we have object on F, and in this case we have object on F also. So this is how we are going to determine focal length. Let's say that we have this concave mirror, but you don't know what is the focal length of the concave mirror. What you need to do is let a parallel light reflect on that concave mirror, and then you can see the image of the object. So the position of the image is the focal point of the concave mirror. Understand? Understand or not?
Yes.
Okay, good. Okay, that is the first case. This is the first case. Okay, now we're going to look at the second case. For the second case, okay, remember in the last week we have learned the second case. What is the second case? Where is the position of the object? The object is more than 2F, right? More than 2F, and then light travel parallel to principal axis. Okay, they're parallel here, and that it will be reflected towards F. Remember? And this one is refraction, so it will be refracted toward F. And then the next rule is it travels straight to F, straight to the center of the lens, a convex lens. There is no refraction, it goes straight on, and then you have the image in the intersection. So here is the intersection. So here is the image. Now, let us try to recall what are the characteristics of the image. The first one, it is inverted. Remember, you can see the image here is inverted. It's downward. The arrow is downward, means that it is inverted. And then you can see the image is smaller compared to the object. So it is smaller, or we can say diminished. And the next characteristic is this is real object, because you can see the light, this light and this light intersect each other at that point. So that is how you determine the characteristic of the image. And then we are going to apply rules on concave mirror. Okay, for a concave mirror, we are going to apply the rule also. So now the object is here, more than C. So light will travel parallel to principal axis, right? So what happens is, will be refracted towards F.
Girl.
Okay, here is the reflection. And then light travels. Okay, now let us try to use the next rule. Light passes through F, and then it will be reflected parallel to principal axis, like this. So where is the intersection? Can you see the intersection?
At of curvature.
Between C and F. You can see that? Between C and F. So here is the image. Can you see that? Okay.
Yes.
Now, what if we apply the third rule? We can apply the third rule, and it will pass through. It will pass through the same point. See, I'm going to draw it here. Can you see? You're going to go through the same point. But in examination, it is enough if you draw 2 rules out of 3. As long as you get the intersection, that is fine. That's enough. So I'm going to leave it there so that you can see. And after this, we're going to use only 2 rules in order to find the intersection between the light, in order to know where is the image formed. Okay, that is okay. Let us look at the characteristic. The characteristic of the image, it is inverted, right? It is inverted because you can see the arrow is downward. It is inverted, and then it is smaller, and it is real. Actually, the characteristic for both of these situations are the same. That's why I'm comparing side by side, so that you can see the differences and also the similarities between the characteristics and also other elements such as drawing and so on. And the next one is the next situation, or the next case is the object is exactly on F. So light travels parallel to principal axis, and then it will be refracted towards F. And then we have another rule. Okay, goes through the center of the convex lens, and there's no refraction. So where's the image?
Image at 2F.
At 2F. Very good. Now you can see the image here. And the characteristic? What are the characteristics? Inverted. What else?
Smaller.
Okay, actually it is not smaller. Actually the same size. Okay, maybe my drawing is not very accurate, but in the real situation, it should be in the same size. And then the next one is real, right? Real, because you can see the intersection here. The intersection determines whether it is real or virtual. We're going to look at the virtual situation later. Okay, now what if the object is exactly on C? Exactly on C. Over here. Okay, we apply a rule, then it will be reflected this way, right? And then you have light travel through C, and then it will be reflected here. So what happens is you see the image. Can you see where is the image?
At
The image
center of
is,
curvature.
yes, over here. at C also. So if the object is at C, the image will be at C also. Okay, with the characteristic, the same size, inverted, and real. So you can see that the characteristic for both situations are the same. Okay, this is the third case. Okay, we are going to learn more cases. Okay. What if the object is now between F and 2F? Between F and 2F, one object is here. Object is here. Then light passes through the lens and will be refracted. And then another rule will apply here. Rule apply here. Okay. Now you can see that the object is more than 2F. Okay, you see the object is here. You can see that? So if the object is less than 2F, the image will be greater than 2F. I need the position of the object. So you can see here the characteristic. Okay, let us discuss the characteristic. It is upright or inverted? Upright or inverted?
Inverted.
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 Correct.
Third.
Okay, what else? Is it real or virtual?
Real.
Real, because you can see the intersection of light. Is it smaller or bigger?
Bigger.
Bigger. Okay, so we have three characteristics: bigger, inverted, and real. And then we are going to do this one. Here's the object. And then how are we going to apply the rule? The light passes up straight line like this, reflected to F, and then light passes through F will be reflected parallel to principal axis. So these are parallel. So where the intersection now? Is here, right? This is the intersection. So the object is, the image is bigger, inverted, and real. So can you tell me the characteristic for both situations? Is it the same or not? Same or not?
Same.
Same.
Yes.
Okay, now let's go on to the next one. Now the object is exactly on F. So light travels parallel to principal axis, and then it will be refracted towards F. And then another rule is light travels through F. Actually, the line should be parallel. Maybe my drawing is not very accurate, but the line should be parallel. So when we have two parallel lines, they will never intersect with each other, right? So you cannot find any intersection on this side. So you try to draw another line backward like this. You still cannot see any intersection. So what we call here is the image is virtual because the image cannot be formed. So the image is virtual. And then what else? This is considered to be bigger because actually this is the reverse case of object from infinity. Object from infinity is very far away and the object should be bigger so that it can be seen from afar. So we consider in this case the image is virtual and bigger, and it is upright. It is considered upright also because we try to find the intersection on this side. So there is no intersection on this side. It is considered as upright. What about this one? Now the object is here, exactly on F. Light travels here, reflected on F, and then okay. Now which rule we should use now? Which rule? Which rule now we should use, in your opinion? Okay, this is not C, as I mentioned earlier. What is this? This one should be C, right? So C, we have C, and we have C here. So what happens is, in this case, like we try to apply the third rule. So in the third rule, light passes through C. Okay, light passes through C. We draw a straight line from here towards the mirror, and then it will be reflected towards C. So the light here are parallel. Okay, this is the rule. But you cannot see any intersection here, and try to extend the line backward. You cannot see any intersection also, because all of them, because the lights are parallel. So it is the same case as this one. So the characteristic is also the same. Okay, now we apply the next. We try to draw. What if the object is closer than F? Okay, this is line and this is line. Okay. So what happens is there is no intersection because the light diverge. So there is no intersection. What happens is, what we need to do next is we draw a line backward like this. Okay, now you have the intersection. However, the intersection is behind the object itself. That's why you need to draw dotted line. Because actually this object does not exist. It is actually a virtual image. Understand? Any problem so far? Any problem?
No, sir.
Okay, now the object is here. In this case, light travels parallel to principal axis. It will be reflected towards F, and light travels to the concave mirror and reflected towards C. Okay, reflected towards C. You cannot see any intersection because the light diverge also. So what you need to do, draw a line backwards, and you can see the intersection over here. The image should be dotted line because it is virtual image. So you can see the characteristic. The image is bigger, the image is virtual, and it is upright. Upright because you can see the arrow. The arrow here is pointing upward. Okay, the arrow is pointing upward. So that are the 6 cases of convex lens and concave lens. I put them side by side so that you can see. Any question? Any question before we go on? Do you have something to ask? Do you have something to ask? You need to ask now. Are you there? Are you there,
Okay,
everyone?
sir.
Okay, good.
Yes, sir.
No problem, huh?
Boleh, sir. Boleh.
Bagus. Okay, saya